In this video, we're going to learn about the mean and standard deviation of a probability distribution. So mean and standard deviation of a probability distribution. And probably more accurately, what this is the mean and standard deviation of a random variable. And that random variable has a probability distribution, and we're going to use the probability distribution to find the mean and standard deviation of the random variable. So to show you this, I think the easiest way of doing that is by constructing this general probability distribution, where this is like the first x value, the second x value, the third x value, on up to the nth x value. And then these are the corresponding probabilities for those values on up to. And then this way I can actually show you the formulas, and then I'll actually give you an example that'll make it clear. So first of all, for the mean, we're going to use the mu symbol, which we learned when we talked about the mean, is what we use to represent the mean of a population. Okay? It also is used to represent the mean of a random variable. So all you do to find the mean is to take each value times its probability, and then you add those together. Till you get to the last one. Okay, so basically you're just taking each value times its probability, and then you add those together and you get the mean of the random variable. So the standard deviation of the random variable, we're going to use this symbol, which is actually lowercase s in the Greek alphabet. So this is sigma, and it also stands for population standard deviation. So this is mean standard deviation of a population. We also use it to refer to the mean and standard deviation of a random variable. And so what I'm going to do is I'm going to show you the computation formula only for this, which is probably the one that you would want to use anyway. So what you're going to do, it's kind of like this to begin with, except each of the values are being squared before you multiply by the probability. So it'd be like x of 1 squared times the probability of x of 1, x of 2 squared times the probability of x of 2, x of 3 squared times the probability of x of 3, and you keep going till you get to x of n squared times the probability of x of n. Okay? And at this point, you've done so much work, it almost feels like you're finished with the calculation, but you're not finished until you take all of this and then subtract the mean squared. Okay? So this is the thing that you put here, but it'll be this value squared. Okay? And then all of this would actually be the variance, or the variance of the random variable. So to get the standard deviation, you actually have to put the square root, take the square root of that. So very much like the mean and standard deviation, you have the variance, and then you take the square root, and you get the standard deviation. So all of that formula gives you the variance. When you take the square root of that, you get the standard deviation. So now let me just show you with a very, very, very simple example. I'm just going to have three values, 1, 2, and 3, and we'll let this be like we'll let this be 0.1. I'll say 0.5 and 0.4. So just really simple, three possible values. Okay, so the mean is just each value times its probability. So 2 times 0.5, 3 times 0.4. And then you're going to add those together. And notice what we're doing here is I am using decimal numbers. So a lot of these you'll have a decimal number here for your probability. So this is 1 times 0.1 plus 2 times 0.5 plus 3 times 0.4. So you're just taking each value times its probability and you add those together. And then I get a mean of 2.3. Okay, so this is the mean of this random variable. So kind of what the mean is it's kind of the average of these. It's kind of where this data set balances, where you're using the probabilities kind of as weights. And so the 4 over here kind of weights things more on this side of 2 than on the other side of 2. So the mean is actually like 2.3, kind of between 2 and 3, because of the weight of the probabilities kind of balancing things on that side. So then what about the standard deviation? I'm going to start here because it's a little bit longer calculation. So what I'm going to do is I'm going to take each value squared times its probability. Okay, but I'm not done yet until I add this. This is part of the computation formula. So I subtract 2.3 squared, like that. And then I take the square root of all of this. Okay, so let's go ahead and try. And what I'll do here, 1 times 0.1 is just 0.1. This will be 4 times 0.5 plus 9 times 0.4. And then I'll hit equals, and all of that is equal to 5.7 minus, and now the 2.3 squared. That's like 5.29. Okay, so now if I actually subtract those, 5.7 minus 5.29, I get the square root of 0.41. And then I take the square root of that, and I get 0.6. And I'm going to round to the tenths place on both of these. And the reason for that is that the value of my variable here is to the ones place. So you don't look at the probabilities for the rounding rule. You look at the x values. And since these are to the ones place, these are rounded to the tenths place. Okay? So this is the formula then for the mean and standard deviation. The mean, you just take each value times its probability, add them together. Standard deviation, it's a little involved, but it's not too bad. You take each value squared times its probability, and then you subtract the mean, what you got for the mean, squared, and then you take the square root, and you get the standard deviation.